All right, let's get started. Good morning, good afternoon, good evening, wherever you are. Welcome to another ArangoDB webinar. We have an exciting topic for you this morning. We're going to talk about our new Neo4j to ArangoDB migration kit. It's a pleasure to be joined by Michael Burleson, our technical account manager, and Nicholas Stachniak, our senior solution architect. So let's take a look at our agenda. First of all, we're going to talk about, what is the rationale for this program? Why did we initiate it? Some of the prerequisites. So what do you need to think about before you engage with this program? We'll go through an overview of the migration kit, take a look at the migration kit guide itself, and then we'll have an in-depth demo of the migration kit and the process that you can undertake to go through this on your own. And then we'll have time for Q&A. In fact, if you would like, go ahead and submit your Q&A through the Q&A feature as we go. And if appropriate, during the demo or during the presentation, we can take those in real time, or we can wait for the Q&A session itself. And then, of course, take more questions then. All right. So again, thank you all for joining. Let us dive in here. My son plays competitive basketball, my teenage son. And I remember years ago, someone telling me, another dad told me, hey, there's a club team for everyone. Doesn't matter what your skill level is. There's a club team that all the kids play on, whether it's basketball, volleyball, football, soccer, whatever it is. Same for databases. Same for graph databases. There's a database for everyone. And I say that because we are not here to bash Neo4j. We're not here to tell you it's an awful product. We're here to basically say that as your use cases evolve, as your skill level evolves, just like in basketball, as your needs evolve, that's where different products come into play. And we're going to tell you why ArangoDB, for some use cases, for some needs, is naturally, we believe, a superior solution. And that's why our prospects and customers have come to us and say, hey, is there a way? So again, nothing taken away from Neo. They've done an incredible job building this market. And it just depends on if you need a basic graph database or you need something that can cover more bases, that's where it comes in. And if you look at what we're hearing in terms of what prospects and customers want that makes ArangoDB appealing, it's around four things. Flexibility, as I said, what can you use that database for? Can you use it for more than just graph? Reliability in terms of uptime, disaster recovery, fault tolerance, certainly important. Scalability, really critical. Can you, and when I talk about scalability, I'm talking about seamless scalability. In other words, as you add data, can it automatically be striped across all the nodes? Especially horizontal scaling. And you don't have to do manual intervention to restripe the data and things like that. All of these three things then contribute down to total cost of ownership in lowering it. So the fewer databases you need, less to license, less to manage, lower TCO, right? You've got more uptime and reliability for failover. Obviously that's going to be lower cost to the business. Scalability, less manual intervention, and of course, then less downtime if you have to have manual intervention, all of these reducing TCO. So let's dive into that just a little bit more. Again, the three questions we hear: is it complete and flexible? Is it scalable? And how easy is it to adopt? So when we look at what we call legacy graph, which are solutions that are primarily graph databases, but then do you need an additional document database to complement that to get a complete solution? Do you need an additional search solution? In many cases, you will. So organizations end up with multiple solutions that they then have to integrate, stitch together, duplicate data. And again, it depends on your use case. If you don't need full document, if you don't need full text search, if you don't need geospatial, if you don't need, right, all those other things in there, then a traditional graph database will do just fine. We also hear that scalability story. And that's where we believe ArangoDB really shines, is in that horizontal scaling and not having to do manual intervention or contemplate data loss as that scaling occurs. So again, there's this notion of these multiple piece parts that you've got to consider and manage. Security is an issue, as we'll talk about in a moment. And so the Arango way is really a single platform integrated from the beginning for graph, document, search, key value, geospatial, graph ML, Gen AI, all on one single platform. So think about that, right? Fewer moving parts, fewer vendors to manage, no data duplication, very elegant. And so you'll get that horizontal and vertical scaling. If you've got one platform for infinite use cases, you can get that flexibility, scalability, ease of adoption, because naturally a single solution, easier to adopt. So what are we looking at? Again, lower TCO, faster time to market because you've got fewer piece parts, get it out there, implement it quickly. But this is the one we hear about. If you go to our homepage, there's a video actually in the healthcare industry page where GE Healthcare talks about this, the security. This is critical in healthcare. It's critical in financial services. If you have to duplicate data across these multiple data stores, and then you've got data out of sync, it's a risk. It's a risk for compliance. And so their key criteria in selecting ArangoDB was the single platform. So they didn't have to worry about all that data duplication if they wanted search, if they wanted a full document model, if they wanted geospatial and so forth. So that's kind of the high-level picture of what the driver is. Again, not taking anything away from Neo in terms of being that really good, solid graph database. And even if you go to their website, right, that's their focus. This is kind of the rationale. So prerequisites. Full transparency, and Michael will show you, this is not a push button affair. This is not push a button and everything migrates. So you do need some technical proficiency here. You do need to understand the basics of graph databases and document databases. You need to have familiarity with these utilities for export and import. You'll need a ChatGPT account. And you've got to have that comfort level with things like command line interfaces, Python, Jupyter notebooks, and so on and so forth. So again, this is going to be a somewhat technically involved process. It's not push button. And we are going to be very upfront with you about what's included, what's not, what's automated, and what's not. Our goal at Arango, again, is to be very transparent and forthcoming with you. The whole idea of the use case aligned with the need, with the solution. And then here again, the idea that you're going to need some technical proficiency. So let me hand over to Michael at this point. He's going to go through the elements of this kit.
Hello. So, as Corey was saying before, there's a couple of different components involved with this tool. And first, we'll go over the three different components involved with doing a migration from Neo4j to ArangoDB. And we'll be going through this pyramid from the bottom to the top, in the order of steps that you'll be doing this. So the first thing you need to do is your data migration. That's the first thing this tool will help you with. So that's your exporting your data from your Neo4j instance, reconstructing them in a way that it will be more performant and will be easier to query in ArangoDB. And it'll be doing this by taking the Neo4j data and splitting it into our documents, which are our nodes, and the edges, which are relationships. The second step of this is going to be determining your functional equivalence. And so this is going to be one of the more difficult parts. And this is where you're taking what is it that you're asking of Neo4j, and how are you going to ask it from that in ArangoDB. And here it's you're going to have the most effort because Neo4j and ArangoDB are fundamentally different technologies. And then any gaps you may find in functionality, this is where you're going to have to mitigate it with changes to your queries. The final step is actually rewriting your queries that are executing against Neo4j into AQL, and they can be run against ArangoDB. as well as validating and testing to make sure it's both functionally the same and that you're getting performant results. So these are the complexity levels and the effort levels for the different steps. The data migration, that's the first part of the tool, which we'll show you in our demo in a couple of minutes. This is pretty straightforward. All you're doing is taking a dump out of Neo4j. Our tool will automatically convert it into different collections and edges and load that into ArangoDB. This is a very low touch process. There are a couple of decisions you'll need to make in order to decide how you're going to represent that data in ArangoDB. But complexity is low, effort level is low. Once you've migrated the data is when the complexity level is low, but your effort is going to be highest, because this is where all of the different use cases that different customers have really come to light. And so there are certain features and functionalities in Neo4j that need to be converted over into ArangoDB. For example, there are things like APOC, where you'll be executing procedures in APOC, like spanning tree and subgraph. These are already working in Arango. These are native to Arango. But there are some other APOC library functions, or if you're using other libraries and functions in general, that might not have a functional equivalent in ArangoDB. In these cases, you'll need to identify it and identify how you'll be writing queries such that they can work in ArangoDB, either by restructuring your data, restructuring your queries, or architecture. And this is where both myself and Nicholas come into play. For anyone after the call who starts using this tool, you can reach out to both myself or Nicholas, and we can give you some guidance on how to best implement your solutions in ArangoDB. But once that's done comes the fun part, which is actually converting all of your queries from Neo4j to ArangoDB. This one, you're going to need as was said before, an open AI account in order to use ChatGPT in order to train your model. And you will need to know the basics of Jupyter notebooks. You don't really need to know how AI works, but if you want to train a better model than the one we're providing, you will need to add an additional data set.
All right. Thank you, Michael. We'll be back to you in just a moment with the demo. We do have a really complete set of materials to support this post webinar, right? We have step-by-step instructions in our Arango Neo4j to ArangoDB toolkit. It includes everything that you're going to see step-by-step in this demo today. In addition to that, linked videos, linked notebooks, linked files, all the different actual pieces that you need are within this document that all of you will get automatically once the webinar concludes. A quick preview of the kit itself, right? So all the phases are mapped out here. All of the toolkit elements are here, right? Step-by-step migration instructions. So it's really going to be a great resource for you in terms of how you can model your data just in a moment. So again, this is going to be a great resource for you post webinar. With that, I think we're going to get into the demo.
So whenever you download the package and open it up, this is what you're going to see. And so just to very briefly go through the important parts is you have your Neo4j to Arango Python script. So this is what you're going to run in order to load your data that's exported from Neo4j into an ArangoDB instance. You have config ini. This is used to drive the Neo4j to Arango Python script. And you have your Cypher to AQL Jupyter notebook. This is where you'll be doing your query conversions. So the rest of it right now, you don't really have to worry about it, but let's go to step one, which is our Neo4j instance. In this one, we're using one of the example data sets that Neo4j provides called network management. This consists of machines, routers, ports, software applications that are running on them, and a graph that describes the relationships between all of these entities. And the first step to migrating some data is first taking the data out of this system. And so in order to do that, we have the Neo4j desktop. And so in order to export the data, all we're going to do is call the APOC export function, which is just going to take all the data and dump it in a JSON format. And I'm going to be putting it into this same directory that we have our other tools. Usually takes a couple seconds and we're done. So if we then go back to our window, you can see that we have our network management JSON, and this contains all of the data that was inside of that database. So the next thing we do is we have our Neo4j to Arango script, and when we run this, this is what you're going to see in the config.ini. You specify your endpoint. So this is one of the prereqs. Obviously, you can't migrate from Neo4j to ArangoDB unless you have both a Neo4j and an ArangoDB instance. So you'll tell it where your instance is, and as long as wherever you're running this, it's able to communicate with this instance, you should be good to go. You give it your username and password. You tell it where the dump from Neo4j is, and you're going to tell it what database you're going to load it into and what the nodes collection is going to be, which we'll get to in a sec. For these are mostly just for performance reasons, or if you want to skip certain loads. We're setting all of these to false because we want to load everything. And the one thing to be careful about is this drop database. So with this demo, we're assuming that we want to completely wipe out the database and load it fresh. So if you're doing subsequent loads, please set that to false. Don't nuke your data. So the first thing that this is going to do, first it's going to scaffold the database in ArangoDB. Right now it's processing all of the data that was pulled out of Neo4j, and it's converting it into a format that's more friendly for ArangoDB. Now that it's finished, it's loading all of the data. It takes about 15 seconds. And so these messages that you see, edge collection not found, that is just because we dropped the database and recreated it. So for each of these collections, it needs to create the collection first. And that's a check to make sure that it exists before we try writing to it. And it should be done soon. So there are 3 different modes that you can run this loading tool in, conversion and loading tool. Mode 1, mode 2, mode 3. So with mode 1, what you're doing is you're looking through all of the labels that's in the Neo4j instance, and we're converting those to collections. And so all of these different labels then get split out and then loaded into their own collections. And then we create edge collections to link them all together based on how they were defined in Neo4j. The second mode that we can run this in is a more simple and I guess naive load, which this might apply to some people and why we have this, which is we only create one collection called nodes, and all of that data just gets loaded into that single collection. And then we have the edges that keeps pointing to the different entities inside that node collection. This is a simpler approach to use, and if you want to minimize your data duplication is the way to do it, and you can split it out later. The third mode that we have, and this is the way we ran it here, is a combination of all 3, which is we create collections for all of the different labels that we have, and we also create this nodes collection to load all the data into. So this way, whenever someone's using it, they can pick and choose how they want to both write their queries and use their data.
And Michael, just to give some background here, the reason we have these modes and have to kind of do these workarounds is the fundamental difference in the architecture, where again, Neo, a graph database without the full document support integrated, they've used these labels attached to the nodes, but not a complete JSON structure. And so
exactly,
that's why we've got to kind of finesse it here, if you will.
Right, exactly. And so, I mean, whether you want to call this a limitation of Neo4j or a limitation of Arango, it depends on the perspective. But
Right.
yes, because at the root of it, we're a document database and a key value store with really good graph processing, and we'll show what that looks like in 1 second. So we have our load has completed, and let's go now to Arango and look at that loaded data. So this is our ArangoDB instance where we just loaded the data into. And over here, we're in the network management database, and you can see all the collections, both the nodes and the edges, or the vertex and the edge collections have been created. And so, for example, if we look at the machine data, we can see what kind of information was stored here. Similarly, if we go to one of the edge collections, let's say exposes, we can see the relationships between the different machine or the different collections. So in this case, the exposes is from the interface collection is pointing to ports. Now, this is where one of the advantages of ArangoDB comes in that once this data is loaded, anything that you can represent in a JSON document can be stored here and queried, and you can build search capabilities on top of that, geospatial, whatever you want. So for example, with this one, if we want to, I can put an owner on this. Let's say this is mine. And there it is, you're good. Now this is something that can be searched for and retrieved. So if we want to see more the graph representation, how Arango's graph engine looks at this, we have this new tool, which is going to be announced shortly. And with this, you can visually explore these graphs. So we start with our machine, and with a double click, we can start navigating this graph. And we can start looking through the different relationships that these machines have. For example, this machine is running CMS, and we can see its dependencies, what ports it's listening on, and what processes it's running. And as well in here, you can also view the data and make modifications to it. So say if we wanted to, we could say has an owner named Nicholas, and we can save that. As well in here, we can create relationships between different vertexes. So we could say, for example, the machine has a service, say depends on, I know that's not what's actually supposed to be here, but so now this runs and depends on PHP. So that's your data in ArangoDB. Now comes to, okay, you've gone through, you've done your functional evaluation, you're ready to convert your queries over. So this is our Jupyter notebook. So I have this running right now on my machine. And what this will do is first it will load a sample training data set that we've developed. It's about 32 queries, starting with both the Neo4j cipher side as well as the corresponding ArangoDB AQL. And so this will be passed over to OpenAI's ChatGPT to refine their model, specifically be able to answer these kinds of questions. And so the first thing we do in this Jupyter notebook, which you'll need to run through, is to come in and then load this training data set. And the important thing is, and this is why we built it this way, is that since every user's use case is going to be different, they might find that after running this training, say 95% of the queries translate fine, but they have a couple of edge cases that aren't really covered by it. Once you've identified what those are, you can add them to this training set to refine the model even further and to allow you to convert more of your queries.
This is because everyone writes their Cypher queries a little differently,
Exactly.
right? And so we want to get that trained so that it's not a generic translation, it's a customized translation. Is that kind of what we're looking at there?
Exactly. And so I will say that ChatGPT 3.5 out of the box does an okay job at it, but it's more like it has like a 60% success rate. Once you refine your own personal model and you use this, it's going to do a pretty good job. But we also want the ability, because we can't see the future and we know that everyone has their own ways of doing these things. There is the possibility that you're going to have some edge cases, and once you run into those, you can further refine your model.
And Corey, to your point, which is really important, each one of these models actually has a unique identifier, and that unique identifier you can squirrel away or set aside, and then you can use that unique identifier to hone your model, like Michael said. So if some of your queries don't get converted seamlessly, you can plug further Cypher into this and teach the model even further than it's already learned, so that it's capable of handling those other use cases.
Great point, Nick. Thank you.
So we load our data, and then we start setting up the actual training session with ChatGPT. And so in here, you're going to need your own license or key with OpenAI in order to run this. But once you do, you'll establish the connection and run the fine-tuning job. So the last time I ran this generally takes a couple of minutes. The last time I ran it took about 4.2 minutes. And then we run through our validation, which is just, here's a bunch of example queries, again, Cypher queries with AQL queries, and we validate that we're getting the correct results. And at the bottom, this is the grand finale, is our chatbot that gets set up at the end of this notebook, in which I have running in this tab. So if I say, I have a couple example queries over here. This is in Cypher saying, I want to find all of the authors who co-wrote a book. So we're looking for author, wrote, book, where it's also the same author that wrote it. We just want to make sure that the two authors aren't equivalent. Usually it takes about 3 to 4 seconds to convert it. And here you are in AQL, how you would, with the same data, how you would write this query and get it back in ArangoDB. So as another example, let's say we want to find all airports that are in the same city. This is also a pretty basic example. Again, there's your AQL that will run. A more fun one, let's find all authors who have co-authored multiple books. So where it has to be greater than 1. Again, there's your AQL query. And yeah, once you have that, you can run through. And if you find that any of these queries functionally aren't equivalent, you can fine tune the AQL and add it to your training session up here, and you can retrain your model.
Hey, Michael.
Yes.
Couple questions. You may have mentioned you can do this in batch if you have hundreds of queries. Is that correct?
Yeah. So you can, once you have this model defined, as not Corey, as Nicholas was saying, you're given an individual token that's part of your account that references that model. And so in the future, you can pass in that model and say, okay, spin this up again and just start feeding in the different queries you want it to translate for you.
There's a sum total of around 32 queries in this example that Michael's showing everyone. So it's not a problem to just use that unique identifier, just like he said, to just add the additional Cypher queries so that you can train the model further.
And the second question I had, Michael, is because AQL is very elegant and it can handle graph, document, search queries, geospatial, all in one query language, which is another huge thing that people love about Arango is AQL. They would do the conversion and then they could add elements to that query. If they imagine you want to broaden your application. Imagine you have a current application built on Neo, but you want to add all these other things, geospatial, search, more robust. You would then extend those queries, correct?
Yeah. So the first thing would be, well, not necessarily. Probably for most people would be adding additional data to the documents that were loaded. So let's say you want to add some geospatial coordinates, or you want to add unstructured text to certain nodes, saying these are notes that were added by an analyst or something, and put a search index on top of that. Yes, then from that point, you could just add the individual conditions into your AQL, and you can start refining the queries from there.
Right. And that brings up another related point, which I think is important for us to be honest about, is that we're not going to rewrite the app, right?
No.
That's not something that this includes. So you're going to have to, there's some engineering that you got to do to point the app against these new queries or use the new queries in the app, correct?
Yes, definitely. And so, yeah, that's going to be the highest lift part, which is identifying the desired functionality out of Neo4j. And once you know those functionalities, you can then validate it once you've translated everything over to ArangoDB.
But again, that's an exciting opportunity I see to expand the functionality of your applications. Would you agree?
Exactly. Because then you're not bound by just graph technology. You can add a lot more, and also you're not bound by a single machine anymore. You can begin to scale out horizontally and add a lot more data.
All right, you actually made that look a little easier than I might have thought. That's really well done there. I do want to move to Q&A now. If you have some questions, there was the one question on, do you have predefined templates? And so I think we showed how predefined mappings available. I think that the export import itself we wrote that for this.
The only mapping that has to occur is naming the database you want to load it into. Besides that, our tool handles processing all of the data, dividing it into named collections, and loading it. There was nothing besides the name network management that was mapped anywhere in the Python code or in the config.
Right. Got it. But the import function is something that we built, obviously, for the
yes,
for
correct.
The data. Okay. Nick, any other final comments from you or questions that you've got?
Yeah, I did want to discuss something that you and I've talked about before, Corey. Probably a lot of folks are wondering about healthcare or perhaps fire sensitive data, perhaps really important geospatial data. And it is important to note within ArangoDB that there are encryption algorithms that can be utilized with the storage engine, which is RocksDB based. And I know you've always made it very clear that you want to make that an important point that customers should take to heart so that they can protect their data. In other words, this is very, very secure. So taking that data out of a Neo4j database, putting it in an ArangoDB instance is going to make it just as secure by utilizing the encryption elements as well. And that's an industry standard cipher of AES 256 encryption that they would expect to see with other products that are database related, whether they're relational or otherwise.
Yeah, it's a great point. And our compliance with the various standards, HIPAA, SOC, all those things is very robust and market leading as well. So thank you for bringing up that point. And I suspect that having all that data in one place is a nice security blanket in and of itself. So
it's very important to point out that once you've moved that data, there's a way for you to make it secure as well.
Yeah.
And it's also important to note that, Michael's a bit of a wunderkind from a technological perspective. This is running in a Python virtualized environment, and you can do all of this on your laptop. So it really is kind of a nice way to go ahead and demo this and show this, and everyone could set this up themselves on their laptop if they needed to, as well as use a cloud instance like Michael did in the demo too.
Yeah, question on the visualizer. When will that be? That's a pretty slick tool there, Michael. Really impressed with that. What is the availability of that going to be?
Within the next couple of weeks. So we're putting some final touches on it right now.
Yeah, no, it looks very easy and intuitive and robust. So really excited to see that. There was a question earlier about support on the, post-webinar support, project support. If you have a project that you believe is a good candidate for this, you would like some hand-holding, if you will, or some guidance, we're happy to provide that in the form of a proof of concept for you. So if you go to ArangoDB.com/contact, you can put in a request there, and then we will follow up immediately to arrange a call to facilitate that support, going through essentially with your data what Michael and Nick showed you today. So that is an offer that we would like to honor. And the question came in, how do we get access to the tooling? We will be sending out that kit, that document I showed you post-webinar. So just give us some patience to run that, or I think it might be automated to get you that document. The document has links in it to all of the resources that Michael showed you today. All the files, all the videos, everything is in one place. So you will have access for that. Thank you for that question. We do have an exciting webinar coming up, another webinar. For those, we saw a little bit of the LLM map to knowledge graphs here in terms of, well, in this case, not really leveraging the graph RAG. This is really what this webinar is about, is graph RAG, partnering with Kern AI, a leading vendor in this space, utilizing ArangoDB underneath for its architecture. And so we're going to showcase how this works, why you need a knowledge graph behind the LLM, how it supercharges that LLM. And essentially, when you look at the results you get just by using an LLM on, a regular database, flat files, whatever it is, you're going to get really poor hallucinated results, but even against a graph without training it. But once you do some training and provide that context, you're really going to get a extremely robust result. And so that's what this is about. And you'll see how they architect this for the application they've built. So very excited about that. With that, we're gonna wrap up. We do have a few more minutes if there's any other questions. Michael,
Corey,
Nick,
Maya asked if there was a link to sign up.
to sign up for that webinar, yes, if you go to our website and go to events, so under company and then events, you can easily register for that webinar. It's going to be great. We've got a bunch of other stuff in the pipeline on LLMs and knowledge graphs, Gen AI. We're taking a leadership role there, and we've got some extremely exciting things. We have an architecture that we're seeing now, we've been told, is much more performant for that versus some of the vector store approaches that are typical. We have an approach that's far more robust and performant for how you would access a knowledge graph from an LLM with in-memory operations. So very excited to share that with you. We've got a ton more lined up on this topic, which seems to be a very popular one. So again, great job, Michael. Really loved what you showed. Yeah, Nick, great color commentary, right? We had our play-by-play guy, we had our color commentator. You had to put up with my comments too and questions. So great job, everybody. And we will see you on the next edition of our webinar series from ArangoDB. Take care, everybody.